Hello dear students, welcome to Vision Pharmacy. In our today's video, we are going to see some basic MCQs based on Introduction to Spectroscopy. So before we start with our today's video, please do like, share, subscribe and press the bell icon for getting updates on upcoming videos. Let's begin students. The first question is, which of the following is an example of absorption spectroscopy? And the options are A. NMR, B. IR, C. ESR and D. all of the above. So students, correct answer of this question, yes, option number D, that is all of the above. Okay, UV visible, IR, NMR, ESR, these all are the example of absorption spectroscopy, whereas fluorometry and phosphometry are the example of emission spectroscopy, right? Moving to the next one. Our next question is, the distance between two successive wave is, and the options for this question are A. wavelength, B. amplitude, option number C. frequency and option number D. none of the above. So yes students, correct answer for this question is option number A, that is wavelength. Moving to the next question. Question number 3 is, which of the following is quantitative spectroscopy? And the options are A. IR, B. NMR, C. UV visible and D. both A and C, that is IR and UV visible. So students, correct answer for this question is option number C. Okay, so UV visible is a quantitative spectroscopy, whereas IR, NMR, ESR and even mass spectroscopy, these all are the qualitative spectroscopy. Okay, then moving to the next question. The question is, Bayer's law states that, and the options are A. intensity of transmitted light increases with increase in concentration, option number B. intensity of transmitted light decreases with increase of sample concentration, option number C. intensity of transmitted light decreases when path length increases, and option number D, that is intensity of transmitted light increases when concentration of sample increases. So students, correct answer for this question is option number B. Okay, so according to Bayer's law, intensity of transmitted light decreases when concentration of sample increases. Okay, then moving to the next question. The next question is, which of the following is not a chemical deviation of Bayer's law? And the statements are A. it follows in monochromatic light, option number B. it follows in dilute solution, that is not in a concentrated solution, option number C. it does not follows in suspension, and option number D. it does not follow in any chemical reaction occur in the sample. Okay, so students, correct answer for this question is option number A, because the statement A is an instrumental deviation. Okay, whereas the remaining three are the chemical deviation of Bayer's law. Therefore, the correct answer is option number A. it follows in monochromatic light. It is related to that of instrument. Okay, moving to the next question. The next question is, Lambert's law states that, and the statements are A. intensity of transmitted light increases with increase in concentration, statement B. intensity of transmitted light decreases when concentration of sample increases, option number C. intensity of transmitted light decreases when path length increases, and option number D, that is intensity of transmitted light increases when concentration of sample increases. So students, Lambert's law, that is about the path length. Okay, therefore the correct statement is option number C, that is intensity of transmitted light decreases when path length increases. Okay, moving to a next question. The question is, number of waves produced each second measured in hertz is? And the options are A. Wavelength, option number B. Amplitude, option number C. Frequency, and option number D. None of the above. So correct answer for this question is option number C, that is frequency. Moving to next question. The question is, the visible region of spectrum extends approximately over wavelength range dash, and the options are A. 100 to 200 nm, option number B. 200 to 400 nm, option number C. 400 to 800 nm, or option number D. None of the above. So students, correct answer for this question is option number yes, it is C. Okay, because 100 to 200 nanometer is for far or vacuum UV, whereas 200 to 400 is for UV, and 400 to 800 nanometer is for visible. Okay, therefore visible range of spectrum extends approximately over 400 to 800 nanometer. Okay, moving to a next question. A next question is, when radiation meets matter, the nature of interaction between radiation and matter may be, and the options are A. Scattering, option number B. Emission, option number C. Absorption, or option number D. All of the above. So students, correct answer for this question is option number D, that is all of the above. Okay, so whenever radiation meets matter, it may either scatter, or it may either emit, or it may either absorb. Therefore the correct statement or the correct answer is all of the above. Moving to the next question. The question is, shorter the wavelength dash, and the options are A. Higher its frequency and energy, option number B. Higher its frequency and lower its energy, option number C. Lower its frequency and higher its energy, and option number D. Lower its frequency and energy. So students, correct answer for this question is option number yes, A, right? So shorter the wavelength, higher its frequency as well as energy. So thank you students for watching this video till end. I hope you like the MCQs. Soon we'll be meeting in next video. Thank you.